Yield in the name of love before you break my heart.
Mr. Samms, I think you need to keep your day job. Besides, you're not even singing the right words.
What do you mean?
Stop in the name of love. Stop in the name of love.
Okay, who's talking about keeping their day job?
But it's stop, not yield. But why are you saying yield?
Because I like to yield better. I don't have to come to a complete stop.
So okay, so you don't like to violate the rules.
I did get pulled over this weekend.
Did you?
I only got a warning, though. I was doing 68 and a 60.
Oh, ouch.
Yeah, it helps when your wife, she grew up with the officer's daughter.
Oh, yeah. Small
helps.
town world.
Yeah. Oh, well. I didn't get a ticket. It was about time, though. I haven't been pulled over in a while. I haven't had a ticket since I was 16.
There you go. So you are actually probably a pretty good driver, huh?
I'm not too bad. I don't.
So, hey, I guess we are talking about percent of yield. So maybe that's why you were saying stop in the name of yield or yield in the name, whatever that is.
Yeah.
I better keep my day job.
Yeah.
All right.
Percent yield.
Percent yield. Not,
percent.
Not yield in the name of love.
And this is it's kind of a different kind of yield. This yield is how much the reaction produces
as a percentage.
Right.
Yeah. So again, we've got a series of rules. So you got to just copy it down. Here's an equation. You may want to put this in the back of your comp book. It's kind of an important equation section.
Yep.
So yeah, why don't you stop the video and write these down? Okay, let's do.
Did you hit pause?
Hey, I bet you did.
If you didn't,
stop. Push pause again. All right. All right, so here's a problem. Hey, we got a balanced. Is that balanced?
No. Yes, it is.
I think it might actually be.
It is. There's 11 carbons. Yep, it's balanced. Okay.
Okay, this is a 1-to-1 ratio. Okay, a student adds 200 grams of C7H6O3. Where did we get this from?
I don't know. I didn't make it up, that's for sure.
Okay, all right. And what else do we know? I have 231 grams of aspirin. That's the C9 problem. Yep. So this is 231.0 grams of this.
That's how much is actually produced.
So what's the percent yield?
Right.
So this is what you're going to do. This is kind of weird. What you're going to do is you convert grams of this, of the reactant, to grams of the product.
Right. But we already have grams of the product.
Not really. What you've got is how many grams you actually made.
Like
this is your.
If I really did this in a lab, that's how much I actually.
This
produced.
is how much you actually made.
So we need to calculate how much we could possibly make, or theoretically make.
Yeah. So what you do is convert that. And you're going to get a number larger than 231.
Hopefully.
Because you can never produce more than 100%.
Well, you can, but you didn't actually get the.
You'd get something else.
It's like contaminated with a bunch of other junk.
Yeah. And then you're going to then divide. So this is actually a simpler problem than the limiting reactant problems that we did in the previous podcast.
I'll take it.
So I'll take 200 grams of C7
I should probably add up that mass,
H6O3. I don't think I could do this in my 12 and 7, 84. 84 and 6 is 90. 90 plus 48 is 138. Is that right?
Yes. Wow.
Grams of
I'm impressed.
C7H6O3. 138. Mr. Bergman is amazing. Okay, 1 mole of C7H6O3.
Write the thing out, people. No naked numbers.
Then I'm going to do the mole-to-mole ratio. This is an easy mole-to-mole ratio.
It's all 1 to
1. So 1 mole of aspirin. I'm going to call it ASP. That's the C9.
ASP. Yeah.
To 1 mole of C7H6O3. One thing cool about this reaction, just as a side note, guys, this is how you make aspirin, like that people eat, or not eat, they don't eat it, but they use it medicinally to cure their headaches and whatever. And then we'll say 1 mole.
My dad takes it for his heart.
Oh yeah, that's true. It's also good for people with heart issues. To so many grams of asp.
Oh, it's probably
9 times.
See if you can beat me to it this time.
108 plus 8 is 116.
180. Beat you.
180. All right, I knew that. I didn't get there. All right, Mr. Bergman doing his head, and Mr. Samms beat me to it. So we now just do the math. The grams here cancel. The moles cancel. The moles here cancel, and you end up with grams. And you end up with a bigger number than 231. It is
261.
261 grams of aspirin.
Unless we want 4 sig figs. Do we want 4 sig figs?
Yeah, I think we should.
260.9.
260.9. That almost like I said 10. Okay. So I'm going to then take what I know. I actually made 231.0 grams of aspirin, and I'm going to divide it by 260.9 grams of aspirin, and I'm going to times it by 100. It looks like a pretty high percentage, 80s or 90s. Mr.
Yeah, we get 88.54.
88.54%. So that means that you were predicting you'd like to make 100% aspirin, but you only made 88.5, which actually
That's not too bad.
is pretty good.
Can I tell you a story?
Sure.
I made this when I took organic chemistry in college.
Yeah, I did
Only I
too.
knocked over my beaker.
Oh, yeah.
And we had to obviously calculate a percent yield. So most people were getting, 60 to 80% yield. I got a
10.
0.5% yield because everything came out
Nice.
except for like these 5 little drops in the bottom of my beaker.
Nice, 0.5% yield. I think I was in the 60 to 80% when I did this lab.